Okay, in this final video of our revision, we'll talk about conservation of energy. I specifically choose conservation of energy because there's a lot of overlap in the questions between kinematics and conservation of energy. I got a bit bored recording you guys because 5 videos a day, so I put a bit of background music. Hopefully, it's not too noisy. Let me know. Anyway, in this question, you are asked to find the distance traveled. So to find the distance traveled, you technically need to find area under the graph. Okay, so I'm going to now start counting the boxes. And when it comes to counting the boxes, I noticed that every area is 4 meter. So I got like 7 big boxes. So it's already 28 meters. I'm now going to draw the area for all the 1 meter boxes. Okay, 2 by 2 is 1 cm lah. Okay, so I'm going to draw that. And as I do that, do you recognize the music? Do you know where it's from? Let me know in the comments. Where do you comment? Let me know lah. Do you know the music? Okay, so I'm counting the boxes. Only those that are more than half do I count. Okay? So all those I put 1, those I more than half I count. No? So I counted 11. So I'll get 11 meters. Alright. So estimate the total distance up the slope. This will be it. Okay. And 39. So your cycle is moving up. The slope has a constant grade. It's a normal inclined plane. 8 seconds to travel up. So you're going to ask me 3 mark what working to show. Okay, so I'll probably show a working that looks something like this. Making sure that I know at every single time there is evidence in my answer sheet the area is being looked for. If the area is not being not estimated correctly, you get 1 mark less lah. I've written the range there for you. So bicycle and cyclists have a combined mass of 92 kg and the slope is 1.3 meter. This is me trying to draw the slope. Okay. By the way, right, these kind of estimation questions, they're not very common, but when they do come out, it can be quite easy to get marks on. Okay. So right now, we are trying to find, because you are going to drop from 6 to 3. So the change in kinetic energy, just half mv square minus half mu square. So half, mass is 92, v square is 6 to 3. So 6 square minus 3 square. Okay. So you get 1247. And to find the change in gravitational potential energy, you already know it moves up a vertical height of 1.3. There's a reason why I discuss structured questions in revision, because they're easier, but I highly recommend you try the objectives too. And come and talk to me if you have questions. Some of you have already made appointments to talk to me this week. So MGH, I'll get 1173. So the cyclist is also pedaling, okay? He pedals up the hill while slowing down. The useful power is 75 watt. Okay, so calculate the useful work done. So you imagine you're cycling uphill, but you're also slowing down. Because it's uphill now, guys. So P is rate of work done, dW dt, W over T here, which is 8 seconds. We assume it's linear now, so this is just average, 600 joules. So there are a few energy in this situation that is changing. Okay, you cycle upwards, you add work into the system as well, but at the same time your GPE is increasing and your KE is decreasing. So it's useful to hold all of this in your head as you look at part C. Some energy is used to overcoming friction. Use your answers, the 3 answers, to find the work done against friction and the magnitude of the frictional force. Okay, total energy converted in overcoming friction is about 670 joules. Of course, you could just randomly plus minus the 3 numbers to see how you get 670 now. Please try not to do that. It's like, here's the key, unlock the door, proceed to bang the hinges. Why? Anyway, so as you go up, your PE increase, your KE decrease. Okay? And your KE, it decreases because there is increase in PE and then there's work done against friction. But you should also ask yourself, right, what happened to the 600 joule? Where is it going to go, right? So you can see here, I've skipped the part where I've forgotten about 600. But the work done, the 600, actually contributes to the kinetic energy. Okay, so if you're confused, you are doing work, you're adding energy to the system. Okay, at the same time, there's also a decrease in kinetic energy. So all this is supposed to go towards friction. Okay, so you can think about it in a sense where you have, by the way, just let me comment on this one first. If you now already have the work done against friction, which is 674, about 670, and then you can find how far it traveled up the slope, which is your estimate just now, your 39 meters. Okay, so if you don't do any work, change in KE will convert to PE plus work done against friction. But you are telling the KE, don't worry, I'm also pedaling. So you're adding on the KE side. Okay? Again, DM me if you need help with this part. So suggest why the magnitude of the total resistive force will not be constant. So as I said before, drag force is like their favorite child. So the total resistive force here includes air resistance, and the air resistance will decrease as the velocity decreases. Remember, the velocity went from 6 to 3. So the air resistance, or this F, is just an average. It's an estimated value. Okay. So once again, in this question, it's an inclined plane. You cycle up, you add the energy together with the decrease in KE. Both of them becomes increase in PE plus friction. So in now this question, you have 2 inclined planes. Let's level up, okay? And they are identical, okay? And M will slide down to B and up to C. We assume that there's no friction, okay? Describe and explain the acceleration of M as it travels from A to B and B to C. So my friends, you want to talk about acceleration, you have to talk about force. There's no other way to explain acceleration but using force. So I'm going to draw the forces acting on this M at point A. You will notice that we have our good friend mg pointing downwards, and the one that is pointing in this side is mg sine theta. Okay, if you need to know why this is mg sine theta, again DM me, I will show you. I might show you in the next revision video when we talk about dynamics. But anyway, the net force on M is the weight component down the inclined plane, your mg sine theta. Okay, that's why the acceleration from A to B and B to C is constant and the same, identical. Because the angle is identical, everything else is the same. So that's the first point. Okay, so the acceleration of AB and BC is opposite direction and is directed towards point B. So from A to B is pointed this way. From B to C, the direction is pointed this way. Now, whenever you are asked to describe the changes, you talk about increase, decrease, constant, and the direction. If it's a vector, talk about the direction, like what I did. Okay? Constant, the same magnitude. Alright? So now calculate the time taken to travel from A to B. Stuva, all over again. Kinematics. Okay? So you want to know the time. Normally when it's time-based, it's easier to find using Stuva. Okay, so this is 15 degree, 0.26. You travel through a distance s. So to find this value of s or AB, you're going to use sine 15 as opposite 0.26 over s. Okay, so you can find s. You want to find t. Release from rest, so u is equal to 0. We don't have v. Okay, so you know F equal to MA, and MA is mg sine theta. So from here, you can see A is g sine 15. So you do have A. We are going to have to use the equation with no V. Okay? So you're going to use these two and substitute it. You have S and A already. So S is UT plus half AT squared. Your S here is 0.26 over sine 15. U is 0. This is half. Acceleration is 9.81 sine 15, g sine 15 t squared. You can find your t. So using or listing down will help you identify, oh, actually I need to find A, then you go and find A. Or actually I need to find S, then you go and find S. Because a lot of times students will ask me, how do I know I need to find these two? You stuva lah, you see what you can get from the equation. Anyway, the time is a very nice number of 0.88, Chinese approved. Now calculate the speed of M at B. So you could say, okay lah, we're going to use V squared is U squared plus 2AS in case the time we calculate is wrong. So we have A, g sine 15, and then you have S, 0.26 over sine 15. Ooh, sine 15 cancel. Beautiful. I like it when it cancels. So you press your calculator, you get V squared is 2g times S, or 9.81 times 0.26, you will get 2.26 meter per second. Or you could say, well, the ball is going to change KE and change GPE. So you equate them and cancel off the m. You can see v squared is equal to 2gh. So you see on that side, the calculation actually looks the same. So when there is no time, you can use conservation of energy to solve most kinematics questions. Which one to use? I prefer conservation of energy because no sign. No need to think of the sign. Provided you know how to use that. Anyway, BC is now adjusted so that it's double the angle 30 degrees. M is released from point A and slide down the slope to B. So how far can B travel up towards C? So I can think about conservation of energy. Okay, so when it comes to conservation of energy, right, whatever GPE it has at point A should be the same when it reaches the new point C. So it should be able to reach back the same height. Because gravitational potential energy only depends on the vertical height. So I'm going to try to draw an inclined plane at roughly 30 using my beautiful laser naked eye, aka agak-agak. Okay, 30 degrees. So the new position here is this C prime, where the vertical height will be the same, 0.26, but it won't travel as far up the incline. Okay, so I'm just going to call this C prime, and we want to find BC prime. If it's 2 marks, I'm not going to show too much working, but I will explain what I told you just now in words. Okay, so M will rise the same vertical height of 0.26 meter because your gravitational potential energy is conserved. Okay, so this one is based on conservation of your GPE. Okay, so if you can rise back up the same height, this one is 0.26. You see this triangle or not? The new angle is 30. You can find BC prime. You just use the same ratio. Sine 30 degrees is equal to 0.26 over BC prime. Okay, so you get 0.52 meter. That's all. Just explain. Of course, you can calculate, but No need. Alright. So the loss in GPE from A to B will be equal to the gain in GPE once again from B to C. Conservation of energy. Alright, let's try another question. This one is a spring. I probably need to talk about spring a bit. So this one, you have a spring, original length 0.4 meter. Then we stretch it all the way to 0.72 meters. Okay, and then we hang a block 2.5 Newton. The block is then released and begins to move down. At one instant, as the block is continuing to move downwards, the spring has a length of 0.72. Assume no air resistance. Calculate the change in elastic potential energy. This is actually the area under the fx graph. So some of you might be thinking, oh yes, let's do this. Half kx1 square plus half kx2 square. So, hey, wait, we don't have k. So we can use f equal to kx. But k here is the gradient of the fx graph. So look for the gradient law. I'm just going to take the extreme value here. Looks like 4.4. Could have taken any other point, up to you. Okay. So here I'll have half. This is not a nice number, so I'm just going to use my calculator now to get the value. And then, 0.72 square minus 0.40 square, right? Right? Then you press your calculator and then you notice, what problem? Okay? Then you might be thinking, why? Now there's a very common problem with spring, because you've forgotten that the spring got original length and then this one is change in length. So your extension actually is not 0.72 to 0.40, right? What should it be then? Okay, if you look at this, the change in length, this one is wrong. Okay, so what can you do is you rub law. And then you notice that actually the change in length at 0.40, this is the original length, so the extension is actually 0. This is why they give you answer so that you can double check and also use up some time. Okay, so 0.35, you are still well within your Hooke's law. So 0.32 square minus 0 square. And this should hopefully give you your 0.6-ish joule. Sometimes people get excited and instead of using the graph to use this. You still use the figure to find the gradient. Alternatively, we can just find the area. So 0.32 is your final extension, and if I check, this is 4. So change in EPE is actually this area, the triangle, from 0 to 0.32. So if I press the calculator for this one is actually 0.61. Chun, betul, ngam. So I'll write that there as a working for you. Okay? As long as you use the graph, it's fine, as long as they don't insist that you do anything else. Okay, so next calculate the decrease in GPE of the block. So this will be mg change in height. So your m is 2.5 Newton. Of course, mg is weight, so you can just take 2.5 Newton for the whole mg. Okay, and then this one you will get 0.8 joule. Right? So use the information in A part 1 and part 2 to determine for the instant when the extension is 0.72. So at this point here. So let's think about the energy. You are storing EPE, so EPE increase. KE is also increased because your block is falling faster and faster. But GPE is decreasing. There's no friction. Okay, so to find the kinetic energy, this would be the loss in GPE is equal to the increase in elastic potential energy and the increase in KE. So 0.64 plus the change in KE, so you can find the change in KE lah. So this kind of conservation of energy is useful to think of what become what. In this case, GPE become EPE plus KE. You stretch the spring, you go faster. Speed of the block will be half mv square minus half mu square. One is 0 because block is at rest initially. Please don't put 2.5 Newton. Don't forget to divide by 9.81 to find the mass. We need the mass. Right. So these small mistakes, it happens all the time to the best of us. Just be a bit careful lah. 1.12 meter per second. Let me know what this music is, and I will see you for revision 3.